A very good morning to you, student. Today I'm going to discuss with you the monotonic function. So what is the definition here? We'll state here down below. So a function fx is said to be monotonic. Monotonic on an interval AB, that is closed interval AB, if it is either monotonic, if it is either increasing or decreasing on closed interval AB. So a function fx is said to be monotonic on an interval AB if it is either increasing or decreasing on closed interval AB. Now let us see what does it mean by increasing or decreasing. So here number one, strictly decreasing, a strictly increasing function. So here let me first draw the diagram. This is the y-axis, this is the origin, and this is the x-axis. The graph here is this. So here let x1 be this, x2 be this. So this is f of x2 and this is f of x1. And here this is the curve y is equal to f of x. So here, as you can see here, as x increases, this f of x also keep on increasing. So such a function is said to be strictly increasing. So here fx is said to be increasing in closed interval AB if for every x1, x2 belong to closed interval AB, okay, with x1 less than x2, it implies that f of x1 is also strictly less than f of x2. So this is then f is said to be strictly increasing, which means that there is certain increase in the values, which means that f of x keeps on increasing as x increases. So such a function is said to be an strictly increasing function. Now, number two, non-decreasing function. So here we draw the graph here. So first it keep on increasing, now it become parallel, and then it keep on increasing. So here this is at the point x1 and this is point x2. This is the x-axis, this is the origin, and this is the y-axis. So f of x1 here is this, and this is f of x2, and this curve is y is equal to f of x. Y-axis is here. So here f is said to be non-decreasing in closed interval AB if for every x1, x2 belong to closed interval AB, x1 less than x2, it implies that f of x1 is less than or equal to f of x2, which means that the value of fx, which means that the value of fx would never decrease with an increase in the value of x. So here now, what is meant by monotonic function? A function fx is said to be monotonic on an interval AB if it is either increasing or decreasing on closed interval AB. So the first thing is that what is meant by strictly increasing? So you draw the graph as the curve y of x, as you can see, it is an increasing function. You take any 2 point x1 and x2. So with fx is said to be increasing on closed interval AB if for every x1, x2 belong to closed interval AB with x1 less than x2, it implies that f of x1 is less than f of x2, which means that the value of fx the value of fx will increase with the increase in the values of x. So as you can see here, the values of fx also keep on increasing with the increase in the value of x. Now non-decreasing function, it is also mean an increasing function, which means that there are points in the closed interval AB where f of x f of x1 is equal to f of x2. As you can see here, you draw the graph first, it keep on increasing, now it becomes parallel, again it keep on increasing. So fx in this case is said to be non-decreasing in closed interval AB if for every x1, x2 belong to closed interval AB, x1 is less than x2, it strictly less, okay, here, but it implies that f of x1 is less than equal to f of x2, means that f of x1 it can be equal to f of x2, as you can see in the graph, which means that the value of fx, but it would never decrease with the increase in the values of x. So this shows that f is a non-decreasing function. Now let us come to monotonic or strictly decreasing. Number 3, strictly decreasing function. So here first let me draw the graph, this one. Strictly decreasing function is this graph. This is x1 and this is x2. F of x1 and this is f of x2, and this is the curve y is equal to f of x, the x-axis, the origin, and the y-axis. So fx is said to be decreasing, strictly decreasing or decreasing in closed interval AB if for every x1, x2 belong to closed interval AB with x1 less than x2, here x1 less than x2 implies f of x1 is greater than f of x2, which means that the value of fx is decreases with the increase in the value of x. So here by strictly decreasing, we means that fx is said to be strictly decreasing or decreasing in closed interval AB if for every x1, x2 belong to closed interval AB with an x1 less than x2, it implies that f of x1 is greater than f of x2. As you can see here, x1 is this point, x2 is this. So the graph of this function, it keep on decreasing. As x increases, f of x keep on decreasing. So such a function is said to be strictly decreasing. Number 4 is non-increasing function. So in this case, x1 and this is x2. This is the curve f of x. Y is equal to f of x, origin, x-axis, and y-axis. So f of x here is said to be, this is f of x1 and this is f of x2. So f of x is said to be non-increasing in closed interval AB if for every x1, x2 belong to closed interval AB, x1 here is less than x2, it implies that f of x1 here is greater than or equal, see the equality sign is there, f of x2, which means that as the value of fx, which means that that the value of f of x would never increase with an increase in the value of x. So non-increasing function means that it is a decreasing function. Fx is said to be non-increasing in closed interval ab if for every x1, x2 belong to closed interval ab, x1 with x1 less than x2, it implies that f of x1 is greater than or equal to x2, which means that the value of fx would never increase with an increase in the values of x. So as you can see in the graph here, the function fx here, y is equal to fx, it starts from here, keep on decreasing, but at some point here, say x1, x2, it is parallel, means fx1 is equal to f of x2, and it keep on, after that, it keep on decreasing, which means that the value of fx would never increase with an increase in the values of f of x. So such a function is said to be a non-increasing function.